for attending the Jeremias University. This is only a 1-hour version of what they usually do in 2 days. This is a very much a flyover representation of what Jeremias can do. So I hope you guys understand that. But we'd love to show you more about this company down the road. This is a really, really impressive company that we've picked up recently. We signed a deal with them. I think it was the beginning of this year, and we're excited to do business with them. And as hopefully you guys recognize Buckley Associates as a manufacturer's rep. We typically represent Greenheck Price, and we have a lot of other complementary products as well, from air distribution to mechanical to control products, and obviously stacks and breaching like this. So we're excited to see what Larry has to say today. He'll show, like I said, a very much a flyover version of this, but we can always show you more about this in the future. So Larry, why don't you take it away?
And
Okay.
hey, Larry, real quick, don't forget to record, buddy.
Got it. Thank you.
No problem.
And thank you, Matt. My name is Larry Rosecap. I'm the CEO. We're gonna have Michael Lucia popping in from time to time to make sure that I don't fall asleep. But we do want to make sure that all the questions are answered, and then we'll stay on afterwards if there's anyone want to have any discussions with anything. So basically, I do want to introduce Jeremias to you, because we know that you probably have not heard of the name before. And then we're going to introduce this all-in-one product system that's very unique. It's a European design. Touch base on engine exhaust, probably spend the most of the time with grease duct kitchen ventilation. Look at some gas vent, ASHRAE, sizing calculations, and wrap up with pressure stacks. So we're going to kind of cover a lot of information. And again, I want to stress that we can do a 45-minute, 60-minute lunch and learn on any one of these topics and spend more time with each. There's a lot of information that we have thanks to our history and background. I want to introduce Jeremias. These are it's a family-owned business. And the company name actually started off in 1984. So this is a very young company in Europe, but today we are the largest in Europe. So the company has grown very fast based upon the technology of the products and the ability for us to build manufacturing plants. So we started in Germany. We built manufacturing plants in Czech Republic, Spain. We have 800 employees in Spain, or in Poland alone. Spain also has a large plant, Russia, UK, and then the newest operations is here in North America. We build 100% of the North American products in Marietta, Georgia, just north of the city. So I do want to just kind of quickly show you real quick. This is our plant just outside of Atlanta, about 75,000 square feet. We have 90 employees already. We've been producing these products for a total of 4-5 years. All the products are actually I should say all the machinery is actually produced in Germany. So we have brought the machines in to the States, but everything is produced in the States with local labor and American steel. So just some pictures of the plant. We also have a lot of inventory, and this is where we get into what's unique about this product line is that, for example, this elbow right here, this could ship out tomorrow as a engine exhaust. It could ship out as a grease duct. It could ship out as a special gas vent for condensing appliances. The type of metals that we use are very unique, and we'll talk more about that. Also, we have our own R&D facility up in Ohio. This is the old metal asbestos lab. Not to date myself, I worked at this laboratory back in the 1980s. We acquired this about 6 years ago, and then we had a full 2 years of entirely going through all the tests for UL standards, which is so comprehensive. I want to brag real quick about our management group. This group has been intact for 3 years. Matt comes from a company called Duravent. He was the director of engineering there. Clark comes from a company called Selkirk or Hart and Cooley. He was the director of engineering there. Francois, our plant manager, comes from Security Chimneys in Canada. Then Maxime is Jeremias, Germany. So we put together a star-studded group of managers in this type of business. We have a young group of engineers doing a ton of calculations and CAD systems for the folks like Buckley. I just wanted to quickly introduce Jeremias, the company, and just to show you that we have been around not as long as other people, not even in Europe, but today we're the largest in Europe, and we are actually on pace to be probably one of the new leaders in this American market as early as 3 or 4 years from now. So any questions or comments about the company, please chime in. You can raise your hand and also. You still there, Michael?
I am here, Larry.
Okay. So to introduce the products, we have two types of products we're using. One's called a KL, DWKL, which stands for conical. I know conical spelled with a C, but in Europe it's a K, so we kept the same terminology. And then we make a flange system like everyone else makes, but we have a big twist on this style of ductwork. We do use 444 stainless steel, which is rather unique. This is a super ferritic steel, very similar to AL294C. You may have that in some of your specs. It's actually approved as an equal, but it does not have as much chromium, which means we can have higher temperatures safely with the 444 stainless steel. I'd recommend every engineer to Google that steel to see what it is and the uses of it. It's very good for corrosion and sulfuric acid situations. We always insulate the products, so the products are always fiber insulated. I'll get more into that in a minute. We only use a 304 stainless steel outer jacket, and then all the supports and accessories are stainless. And because of the type of the design we have on this joint connection, we actually have the highest pressure rating on the market, 90 inches of water column, and that's with no silicone, no gasket. Very unique style system. And then the one product basically covers all 16 listings because of the type of steel that we use is the reason we can do that. So this is a conical system. This is what's used on the smaller diameters up to 18-inch diameter or 16-inch diameter. It's a very unique system. We say it's a push to fit and tap to engage. So this is a conical system that was actually invented by Jeremias back in the 1980s. The patent is up, so this is more of the standard pressure stack system used in Europe for all condensing appliances and even other applications. So this is the standard in Europe, and we're bringing this into the American market. You form the conical, which this illustration is exaggerated. You simply push the two pieces of pipe together, and then they're pushed or tapped into place, and that forms the connection. There's no gasket, no lubricant, and that's what we have. That's what we have, the 90 inches of water column of pressure rating. On the double wall system, we actually shove insulation between the walls, and that insulation is what holds the inner and outer pipe together. We actually wire cut this mineral fiber, or we compress the ceramic fiber to make sure it's holding the inner outer pipe together. So these are actually floating inner and outer pipes. The one side of it is expanded right here. So when you push the systems together, you still have flashing going down. So rainwater outdoors, again, no sort of silicone or anything like that's required. And then you add an outer band to hold the outer jacket in place. So again, this is a very unique system. What's great about this is that using this insulation means that we have no brackets, no spot welding. I can actually sell this fiber insulated stack system for less cost than our own airspace systems. So basically you get this fiber insulation for free. Now on the larger diameters, up to 48-inch diameter, we go with a flange system like everyone else does, but we have a very unique twist on it. We expand one side, and then we add the flanges to the pipe on the outside of the pipe. So when you caulk the larger systems with silicone, and when you install the system, and then you install it with a V-band here, the flue gases or the condensate do not ever touch or influence the gasket. So this is the reason for this added or this extension of the inner. So this is critical because we are seeing a ton of these stack systems, the American style flange systems, leak because you're putting the silicone on the flanges the system goes together, and what you actually have is little slight bridges that hold condensate, or the gasket itself is actually influenced directly by the condensate or high pressure steam washing on kitchen ventilation systems and so on. So this is why all these systems are really leaking a lot, and this is why you want to have the overlap system.
Hey, Larry, real quick.
Yes.
How long does it take for that silicone to cure once you put it into the pipe that others are using versus us? Because I know ours isn't exposed to the airstream, right?
Right. I
So
mean, others can take up to 7 to 14 days because they're using fire caulking. If you look at the prints of some of the other manufacturers on kitchen ventilation, so that's a good point. We don't have any cure time because the silicone's always outside the stream. Thank you, Michael. So the products we just showed you actually are listed to all 16 of these UL and ULC listings. And I like to show this slide just so everyone knows that this is a timeline of the UL standards. 1950s was the type B, 1960s type L for oil, 1970s was the 103 pressure stack systems, 1980s was chimney liners, 1990 was special gas vent for condensing, and so on. So the idea is that we came in 6 years ago and we had the product, the same exact product, tested and listed and approved for all the UL standards throughout the decades. So that's one of the benefits for Jeremias coming in very late to the game. So that's just an introduction of the products that we're really not going to be talking anymore about. I wanted to introduce the company. We introduced the products quickly, and so I spent just a few minutes on that. So now we want to spend the rest of the time talking about applications. Basically, we're talking about engine exhaust just shortly. We'll spend most time probably with grease ducts, and then the rest of the time with gas vents and pressure stacks. And keep in mind, any one of these applications, or even when we get into the ASHRAE Chimney Design Equation, we could spend a lot of time on with any of these topics with you. So engine exhaust systems, this is a very good market. We actually start at 3-inch diameter. I know that I walked through the city of Boston and I saw all these 6-inch diameter engine exhaust systems on some fire stations, and they had a 3-inch outlet. These exhaust systems could be 3-inch, but they had to put 6-inch diameter factory built because no one else besides Jeremias goes down to 3-inch diameter. Now, when you do specify the factory built systems, keep in mind that everything is taken care of for you, the details. We just like to show you some of the details. First, we supply the Ansi flange connections. So this is a stainless steel plate, which is mounted directly to the Ansi flanges. We actually make a stainless steel relief valve, but I want to make a note that Jeremias is the only UL listed system that does not require a relief valve. That's because of our pressure rating and the way we stiffen our elbows. So we do not require a relief valve like Schedule 40. Now, we supply all the anchor plate support, so you have a lot of expansion. For example, 10 feet of stainless steel ductwork is going to expand 1 inch at 1,000 degrees and then contract again. So what we do is we anchor the plates at every change of direction. We supply the bellows whenever expansion exceeds 3/8 of an inch. We supply all the struts and guides to make sure that the pipe stays intact. All the drains, we always put drain sections on engine exhaust systems. You have a ton of condensate at startup. Some of the accessories I want to point out, the insulated roof thimbles, no ventilation needed. The bellow joints are actually lined. Again, all stainless steel parts. The guide rings, the supports are all stainless steel. Make sure that when you do specify a factory built system, that the factory's doing all the calculations for you. You're going to see that you're going to typically see smaller diameters. So you get the engine data sheet, which is typically a 2-page sheet that shows all the information on that, the silencer information with the pressure loss, and the manufacturer should always be able to do pressure calculations. We require it for our extended 25-year warranty to make sure we have pressure calculations on file. Just a couple quick reviews. I mean, this is a 3-inch diameter system. in New York City. All the fire stations there after Irma had to put in some emergency backup generation. So we're actually using insulated pipe where it's available to be touched, and then we switched to single wall pipe going up the outside wall that's made of non-combustible materials. Again, this is an entirely stainless steel system. It's going to look this way for years to come. A couple other projects on the East Coast. The brackets are all stainless steel as well. So just a little bit on engine exhaust systems there. We're going to jump right into kitchen ventilation. This is the fastest growing market for factory built systems because this is for the first time probably in the past since the history of factory built, the factory built systems are actually less cost than welded steel, than insulating it twice in the field. So the great thing about this is that you have one installer and you don't have to have multiple trades when you do a kitchen ventilation system. Also, I want to point out the new rectangular systems on the market. There's 3 of us manufacturers that make a rectangular system. A 4th makes a flat oval, so these are becoming more and more possible. These are harder to clean. We do prefer round because round is less cost, but the rectangular does take, it is harder to clean, and it does cost about 20% more than round. So we like to start off talking about one of the largest projects we've done. When we first got started 4 years ago, we supplied 5,000 feet of grease duct for the Atlanta Braves Stadium. This is a new stadium built. And because the product was brand new, the local authority said, look, you have not been building this ductwork very long. I don't have any examples. They made us go through and pressure wash the entire 5,000 feet after the installation to make sure the system was going to install and not leak. And I wanted to kind of show you, this is how folks are, most of the time, this is how they are cleaning ductwork systems today. So this is a high pressure steam jet of about 1,500 feet per minute, I'm told. And they went through the entire ductwork system to make sure there was no leaks. And by the way, they did find 2 leaks on that 5,000 feet, but they were very impressed. The low sections that were coupled was easily fixed in the field. But they said typically when they high pressure steam jet these grease duct systems on a welded steel stack, they see these leaks every 15, 20 feet. So we like to point out a little bit about the purpose of round being easy to clean, and also the leak-free designs of the Conical. You basically have three options with the factory built. You can use a single wall system and still insulate it in the field. So this is an option for just welded steel. You can use a reduced clearance option, which our system has a 1.25 inch thick fiber, which gives you a 2, 3, 4 inch clearance to combustibles based upon the diameter. This is typically used on single story restaurants, buildings, or maybe a fast food restaurants. And then the third option is the zero clearance and fire rated shaft assembly. Our model has 3.25 inches. Other models on the market have 3, some have 4, but it's always between that 3 and 4 inch range for the zero clearance fire rated assembly. Now, what's great about these products is you can actually mix these models together. I mean, for example, down in the kitchen, I could be using reduced clearance, and then before I go through the first floor, I change to the zero clearance. And then maybe if I'm above the roof, I can use single wall. So you can really mix these up because the price difference between all 3 models are extremely different. So let's take a look at an example layout. We're going to look at the connections at the hoods. We'll take a look at the supports and then through the roof penetrations and connection to the fans. So the hoods are by others, so you want to make sure you are specifying a no weld transition or hood adapter. A lot of hood manufacturers are making round collars today. Most of them ship it out with the collar not attached when they're going with another ductwork system. So we have a no weld hood transition that connects to a hood that has no collar on it as an option as well. We like to use low loss elbows. Our access panels are very easy for us to make. We have 3D laser technology, so we can make these for almost next to the cost of a straight pipe length. So we actually have a lot of inline access panels with our style of grease duct systems. All the supports, hangers are taken care of. Again, this illustration right here has an access panel here, 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 and there. So you have actually 4 access panels, and then the vertical support of the stack is provided by the factory also.
Hey, Larry, real quick question for you.
Mm-hmm.
Is there a code or a rule of thumb of the distance between inline access doors?
Yeah, we follow the local codes. NFPA 96 states have 12 feet spacing, and then the IMC has 20-foot spacing, and also at every change of direction. So thank you for bringing that up. We do follow the local codes as required for access. And then when you get into large ducts, especially the rectangulars, typically anything larger than 20 by 20 or 22 by 22, you can have a man access to eliminate all the access panels. So we have the roof penetrations. In this case, this could be maybe a 24-inch diameter duct where we have a single access at the top going all the way down. Now, I do want to show you some of the testing that goes on with factory-built systems. This is one of the main reasons that people should be specifying. This is one of the reasons that consumers, customers are wanting a factory-built system because of the safety of the UL listing. So I'm going to show you some pictures that we are doing in our labs. First, introduce a couple. I mentioned Clark Pridemore before. He comes from Selkirk. Rod Carr was also at Selkirk for many years. They're working with us at Jeremias now and inside the lab that we looked at. And we're going to be looking at some test procedures for this 2,000-degree abnormal test. This shows what happens, or this test is to simulate a kitchen exhaust fire, which happens all the time. Actually, NFPA 96 talks about $200 million of direct damage due to kitchen fires every year. So just to start with, I want to show everyone what a 2,000-degree stainless steel duct looks like. So this duct we're seeing pictures of is at 2,000 degrees inside our lab. So let's talk about the test procedure. This is a 2,000-degree test for 30 minutes. We take a test subject that's about 15 feet horizontal, 10 feet vertical. We put a flue gas generator and we fire flue gases into this test subject. We're actually measuring skin temperatures with thermocouples to make sure that the clearance to combustibles is what we say is safe in our instructions. So that's the test setup. That's what it looks like right here. This is a 8 million BTU burner, and we're actually firing flue gases through this flue gas generator into the test subject. And I got some videos to show you. This is a very sobering type of system to hear. It sounds like a jet engine. I'm going to get into the video here. And what we have actually is a 37-minute video. So I'm going to fast forward this very quickly. You can see that 10 minutes into the video, we get the red hot flue gases on the flue gas generator. And this video is during the actual UL witnessing of the test. So you see the guys walking around, making tweaks to the burner, measuring the the skin temperatures. So we want everyone to understand how long this 30 minutes is. That's why we want to go through this quickly. Because what we did is we thought we would take a carbon steel system and put it through the same test. Now that video is much shorter. We like to talk to people one-on-one so they can make guessing, but we actually did a 16-gauge black steel duct system. We double wrapped it with fire wrap that's required by the ASTM E2336. And this video is much shorter. This video is about 3.5 minutes long. And what I want everyone to focus on is looking at the middle of the flat horizontal ductwork. Watch how it starts to collapse. So you have the ductwork that's collapsing very quickly because what's carbon steel going to do at 2,000 degrees? It's basically melting. So we turned off the first test after 3 minutes, and this is why you see a lot of this information in our literature. On the left-hand side, you see a round system made of stainless steel. We've put this through maybe 11, 12 of these 30-minute tests. It just doesn't bother stainless steel, especially 444. Look at the right-hand side. That's the carbon steel system after 3 minutes. Now, we do a lot of work in New York City, so we know that the 12 gauge black steel is the standard there for a field welded system, 12 gauge. So what we did, and we're working a lot with the authority there, we actually brought these folks into our lab and we tested a 12 gauge black steel system. Now this video is a little bit, the marketing people got a hold of this, but we was able to actually stage this a little bit better to be able to control the results. So this is a little bit fast forward. You can see how we kept the heat on the ductwork there. And the funny thing is that the 3 minutes into the test, you basically had the result as the lighter gauge. So the thicker gauge did not help out any when we talked about the 2,000 degree test. Now, a second test I want to talk about is the UL engulfment test. So this test is for 2 hours for the 2-hour fire rating. What we have is a similar test subject right here, and you're placing the subject inside an oven, and so you're heating the outside. The fire side is on the outside of the ductwork. And what you're really doing also is you're testing the through penetration fire stops to make sure it's containing the heat as well. Now there's 2 of these ovens in North America. One's in Chicago, that's where we're looking at for the UL laboratories. The second is in Houston, Texas, which is the Intratech ETL labs. So we'll take a quick look as Clark is walking through the inside the oven. This is before they fire the oven up, obviously. It's the system that's just installed. You have to make sure you install the system per the instructions. And then you fire the oven up at 2,000 degrees for 2 hours. So that's just looking through a weave hole. After the 2 hours, they take and they raise up the complete assembly and they spray it off with a fire hose until it's cooled down. So after that, this whole test, the product has to be seen suitable to handle the kitchen exhaust. At the same time, the through wall or through ceiling penetration must have kept the heat intact. So this is a pretty stringent test, a pretty hard test. We can see that carbon steel system would not hold up very well to this also, but this is a $90,000 test, so I'm not going to just simply go test a carbon steel system to see what that looks like. So this is a very expensive test that all the manufacturers have to go through, the UL listed grease duct manufacturers. Now I want to talk a little bit about cost because that's always important. The person that really benefits, again, is the owner, not the contractors. Now we looked at a 22-inch diameter round system. This had about 12 or 13 different risers going through a very tall building in California. So we actually did some cost analysis that the local contractors agreed with, because when we try to sell our UL listed 2221, we say $3,000 per floor. They say, like, what are you talking about? I can do it for $400 per floor. But then he has to install that. It takes longer to install. Then he has to buy the insulation. They have to wrap the insulation, and they still don't have a real shaft, so they may have to put a additional 2-hour rated shaft in. So we're looking at $4,400 per floor versus the expensive system down here. They're simply connecting the system together, and you don't have to worry about a fire rated shaft. You can just put a standard wall construction up, not having the expensive fire rated doors. So what we want to look at are these numbers here, 3,600 per floor versus 4,600. Who benefits is actually the owner of the building. Also want to point out that we get a lot into balancing. So if you have multiple hoods, let's say that you needed 1,000 CFM at both of these locations, this duct actually shows 100 feet here and only 10 feet on this side. And by using different style of fittings, we can actually balance out the hood systems. The largest balanced hood system we have without using dampers, there's very few of these UL listed dampers made, by the way, and they have to be installed vertically above the hood. But without using dampers on a 16 hood, we did a 16 hood system in Texas. So just quickly, just to review on kitchen ventilation, I do want to mention that I mentioned the Atlanta Braves Stadium. This was a job where the contractor was responsible for the welded steel, and he also was responsible to insulate the ductwork. So that's the reason they used our double wall system here, double wall insulated system here. And then the Atlanta Falcons is another good example, more than $1 million of ductwork. We offered a complete package to the sheet metal union. It was about $3 million, and we should have got something like $1 million back from the insulating contractor, and they offered $100,000 back as a deduct. So we went back and we supplied single wall on this system, and then the insulating contractor still insulated it like you would the factory, or like you would the field welded. So again, depending upon if it's specified up front or the contractor's involved, sometimes we use single wall, sometimes we use double wall, but always if it's specified up front with the correct factory built systems, the owner is going to benefit in price. Okay, it looks like I'm a little bit behind schedule. I want to go through some of this fairly quickly. I hope everyone is still with me. Michael, you still with me?
I'm here. I am here.
Quick gas vent introduction. We do want to talk about the Ansi venting categories, because this is really only about a decade old. But here's the introduction of the gas vent systems that we have. We make a double wall system, which is airspace, which is good for all categories. We make a single wall system, which is cut to fit, very unique. That's not for category 1, everything else. And then we make a type B gas vent called Echo. Now, something about the materials on our gas vents, as well as the original conical and the flange system we talked about at the very beginning. I did mention 444. It is being melted for the first time in the States, thanks to Jeremias. I should mention that AL294C is no longer the requirement by the appliance manufacturers. All the IOMs say AL294C or UL 1738 equivalent. We actually use 316 like everyone else does on large diameters above 36 inch. Like the conical and the flange, we always use 304 stainless on the outer jacket because again, the systems are always maintenance free. That's important. And like always, the supports and the accessories are all stainless as well. Now what we do on the gas vent system, the small system, this is being sold through a lot of distributors. They like stocking the single wall systems because it's filled cuttable just like plastic. So we expand the female side, we add a gasket right here. So it just simply pushes in, you have that full 2-inch overlap. This is important because the pipe can be cut to fit in the field. Contractors love this system. They can just go pick up a handful of 4-foot pipe links and some elbows, and they can just cut the links to fit in the field. And that's also a better for the product as well. And the less joints you have, the better you're going to be. On the larger diameters, we use the same FL design flanges to the outside of the pipe. So when it's caulked, you have the flanges protecting, or the sleeve protecting the sealant against the condensate. Again, we talk about the flange to flange system. We're just seeing a lot of these systems fail. Jeremias is already replacing a lot of these systems, in this marketplace. So if they don't leak right away, they will eventually. I mean, some manufacturers have like a 2 or 3 year leak-free guarantee. Again, our warranty, 25 years is the warranty of the product. Some options on the gas vents. You actually have 7 different temperature listings, and we actually, like everyone else, they choose either 550 or 480, but we actually went down to 400 because condensing boilers today, they never exceed 360 degrees Fahrenheit. So we did a 400 degree temperature listing so we could have 0 clearance to combustibles, taking advantage of that insulation, that fiber insulation that's automatically added on the Conical system as well. So we can actually get 0 clearance to combustibles on any condensing appliance, and then we actually got the product listed and approved for plastic applications as well. So you have 0 clearance to combustibles for all the plastic applications, both the single and double wall. So the single wall, again, includes the plastic applications. So you have a 0 clearance to combustibles, except for the PP on the enclosed horizontal. So we think this is important because we see more and more areas not allowing non-listed PVC, CPVC used for venting. I want to point out that maybe at 6-inch diameter, the single wall stainless, which includes a distributor markup, is nearly the same cost as PPS and CPVC. And the larger we go, the larger diameter stainless looks more and more important. Of course, the United States is the only country in the world that allows non-listed PVC to be used. Up in Canada, only listed systems. All throughout Europe, they have nothing like PVC or CPVC there. Everything is polypropylene because it's 100% recyclable. Or stainless steel. Stainless steel is actually coming back on the condensing side, becoming more popular than polypropylene throughout Europe. Now, I do want to talk about this Ansi venting categories. Every appliance is stamped and shows what a category it is if it's a natural gas only appliance. So again, the OEM or the label defines the category, but category 1 appliances would be anything that's atmospheric or maybe fan assisted. It's basically non-condensing, also requires a negative vent pressure. Category 2 is sort of phased out because this is what the category 4 appliances use to define how to common vent. Direct vent systems, category 3 would be something like a tankless water heater. It's not condensing, but it has a positive vent pressure. You're pushing the flue gases through the pipe. And then category 4 would be the entirely condensing appliances that may or may not be able to use plastic PVC systems. So really what these categories tell us is what type of material to use on the venting side. So category 1 requires UL 441 standard. So that's type B gas vent. So UL 441 is a type B gas vent that can only be used on category 1 appliances. So we have a type B gas vent, and also our standard double wall gas vent has that listing as an option also. It's actually standard that the double wall gas vent includes that listing on it. Category 2 is when we move into a new standard, UL 1738. So typically the requirement is our single and double wall special gas vent. Category 3 remains that UL 1738 special gas vent. And category 4 again remains that UL 1738. Or it could be approved for maybe PVC or CPVC or polypropylene. So just a quick review. Again, our DW double wall gas vent is good for all categories. And then type B gas vent is only good for category 1. A little bit about sizing these systems. We use the ASHRAE, we use the National Flue Gas Code to size category 1. These are the venting tables. It's also good that we know about these venting tables because they have a lot of rules. So actually our tech team goes through these venting tables a lot to learn about all the rules. Sizing category 2, this is a combination of ASHRAE and the venting tables to understand the rules. And then on categories 3 and 4, how we size the gas vents, it's basically equivalent length or allowable pressures. Allowable pressures is becoming more and more popular because of the everyone has access to the electronic or computer chimney design equation. So I do want to talk about this chimney design equation. I'm going to go through this very quickly. Please try to follow me, pay attention. We spend hours going through theory in our university systems with the reps, but this equation is a way that we can calculate theoretical draft. We calculate the pressure loss, and then you add these two up together, and that's what you measure at the outlet of the appliance. So we take a look at a 1 million BTU heater, a 10-foot tall stack, a 10-inch diameter flue, and we can calculate a 0.06 inch amount of theoretical draft. We can calculate of all the flue gas volume going through that conduit, a 0.035 inch water column of pressure. And you do the math, negative 0.06 plus 0.035 is a negative 0.02. That's what you would measure at the outlet of the heater. Now, when we get into theory, we talk about the priming period. I mean, you don't get that negative 0.02 until like a couple seconds after, but a complicated system could be minutes after startup. So we have a negative 0.02 on this one. Here we added 5 feet of horizontal, a couple fittings, draft stays the same, pressure loss increases a lot. So when you do the math, you're now measuring a positive vent pressure at the outlet. That means you're having flue gases spilling out of the barometric damper, or the combustion is now changed. You don't have as much excess air. Here's a stack that's 3 times taller. Now we have 3 times the draft. Pressure loss is minimal. You do the math, and now we have a high negative situation. So if you have maybe a barometric damper on this, all the room air is going up the stack. If you have a draft hood on the system, again, all the room air is going up the stack. So I want to show you just a quick example on how the factory chimney people look at these systems. So let's say we start with a UL listed tank heater, and they like to see a slight negative pressure at the outlet. They ship it on the job site with an 8-inch diameter outlet, so the 8-inch outlet right here. And by the way, they test it with a 20 feet vertical tall stack at the factory. So let's say we have a couple fittings. We do the calculation. We see that you do the math, and we say positive vent pressure at the outlet. This is where we stop and say, okay, something has to change. We need to increase the draft. We could make the stack taller. You know, Jeremias would love to see all the stacks around Boston 50 feet above the roof line. You have to decrease the pressure loss. One option is a mechanical draft fan, but that's the last resort. You always want to look at gravity vent systems. So the way to reduce the pressure loss is to change the stack diameter. So on the next slide, we're going to change the diameter to 10, redo the calculation, and now we're back to a slight negative pressure. So you see we went from a 0.19 pressure loss to a 0.07. So again, we're back to safe venting. Let's say you only had 10 feet of stack. Now the draft is half as much. Now you're back to a positive vent pressure. What do? We use a 12-inch diameter. We have an 8 to 12 increaser right there, and this heater is thinking like it's going straight up 20 feet with an 8-inch diameter vent. So these are actually some real numbers. We kind of laugh about this. Only contractors would actually see this, but theoretically you have to increase to 14. We would stop at 12. We don't increase the sizes more than 2 sizes because of simple velocity sake and some rules of thumb on the National Fuel Gas Code. But this is just a quick example. Now, everything we looked at was a dedicated stack. So when we start combining appliances together, condensing or non-condensing, forced draft or condensing, we always got to make sure that the various pressure range is always acceptable by the appliance manufacturer. So no one knows more about all the appliances out there than Jeremias. We work closely with all the appliance manufacturers. So again, we can go in very much depth with this chimney design equation with your engineers at your office at any time. Okay, if the appliance is not categorized, We call it non-categorized appliance stacks, or otherwise, a lot of people know them as PS pressure stacks. So that's a UL 103 standard, which is a 1,000 degree temperature listing. Some go up to 1,400 degrees, and all of these are listed, all of them are listed at 60 after 1,000 degrees, where Jeremias is listed at 90 after 1,400 degrees. The reason we did that is because we want to make sure that you could easily add Jeremias to your specs, the name, because we exceed every part of your specification. Also, the building heating appliance chimney could be maybe cooking ovens or manufacturing style ovens. Of course, the water tubes and cast iron type of heaters. I know these are very common up in the Northeast. So just a quick review, again, 103 is another listing that we didn't talk about. And of course, the same products we looked at the very beginning was the Conical and the Flange. That's one of the 6 different United States UL listings it carries. Now, just as a quick review, we're going to wrap things up here shortly. We didn't even talk about commercial laundry exhaust, which is a very common thing. The natural gas ones actually have flue gases in the exhaust system, so your exhaust should be rated for flue gas. Our Conical is in the flange system. A single wall has 0 clearance to combustibles at the 220 and below temperatures. Fume hood exhaust. Engineers, once you start looking at the 444 stainless, you're going to recognize that this is better than 316 on sulfuric acid applications. So we're seeing a lot of no weld fume hood exhaust venting out there in the marketplace. But I didn't mention dishwasher exhaust. Every time you have a kitchen exhaust system, contractors like the pop together system on the dishwasher exhaust as well. Pizza ovens, wood burning pizza ovens has become popular. There's a little add-on to the 103 called HT, UL 103 HT. Only 3 of us manufacturers have that HT added on. That's a 2100 degree burnout for 10 minutes, 3 times to make sure that the product can handle above 2000 degrees. Of course, we talked about the kitchen ventilation, maybe a single story application with reduced clearance grease duct. We touched base a little bit on special gas vent. We talked about the boiler stacks, UL 103. We talked about the plastic applications. We're seeing again, our single wall stainless is a viable option cost-wise and versus a non-listed, non-warranted plastic. We do a lot of chimney lining systems. We have a dedicated chimney lining division of the engineering group that handles up to 300-foot tall liners. These are custom engineered liners that actually may include the base going down and self-supported style systems. So we have a nice group there. We do a lot of added features like cantilevers. This is 20 feet freestanding, and we don't have guy wires. We don't like to use guy wires because that's maintenance. Again, the reason behind the 304 stainless outer jacket and all the 304 stainless supports is that the system is maintenance free. These stacks are growing, contracting, expanding all the time. You don't want something that's painted or galvanized or aluminized. Think about specifying a 304 stainless to outer jacket, but we actually, in this case, we designed this cantilever, which is made of stainless steel. We made it in the shop, and we provided the engineer with all the FEAs to show how the system is more than adequate. Here's a data center. We designed this freestanding backdrop here. So it is attached to the data center, but it's not supported to the data center. So this is entirely a freestanding structure to keep the moments of the wind and the expansion, contraction off of the data center wall. We also do a lot of these mast systems. These are freestanding masts. We design and build these. We design these for the engineer and build them, and then we supply the standard lightweight stainless steel exhaust. This is a much less cost than a freestanding stack system. So keep in mind that you get into some large projects, we can take care of that. There are 10 flat specifiable features. I really don't want to get into this, but No, we have the idea behind this is that Jeremias is new to the American market. We want to make sure that you're confident that we exceed all of your specs. It's really a world-class style of connection with the overlapping joints. Every system we make has an overlapping joint, and that's extremely critical with the highest pressure rating and the temperature rating as well. So we're going to wrap things up. I thank you all for attending. Michael, you still there?
I'm here, sir.
Okay, so make sure to let the Buckley guys know if you want a certificate or anything else. I think we can look at some questions online. Please, I would invite everyone to have a chance to take a look at any one of these things we talked about in greater detail. We'd love a chance to have like a go-to meeting style setup versus a webinar, so we can have discussions. So I'll just wait a little bit to see if any questions or comments. You can see that also, Michael.
Yep, there's nothing in chat right now.
This is Jerry Alverson at BVH. I did put 3 or 4 questions in the chat. I'm not sure why you're not seeing them.
Really? Okay, I apologize about that. All I'm seeing is from Vince and Matt saying that they were muted. But go ahead with your questions. I apologize for missing during the presentation.
Okay, so one thing is zero clearance grease duct. I understood that it acts as its own shaft, so that means I wouldn't have to have a separate, where I need a rated shaft for other things. I could put this in the same shaft and not have to have a separate shaft?
Correct.
Because, okay, I thought that's what you meant, but I wanted to be sure.
But in a lot of cases, they actually use it by itself, and then the shaft around it is not really a fire rated shaft. It's just a single drywall wall that to have access to the grease duct just requires a standard door type of setup, not a fire rated door. So do keep that in mind as well.
Yeah, right. But if I do need a rated shaft for other things,
yes,
I'm allowed to put this inside that same shaft instead of it having to be a separate shaft.
Correct. Yes.
Okay.
In some jurisdictions, they even allow our reduced clearance to be placed inside the shaft, as long as you maintain the 3-inch clearance to combustibles, because that's about half the cost almost. Go ahead.
So we do quite a bit of public work. Requires us to list 3 manufacturers. So, what would be the appropriate competitors, or is there anyone else that can kind of meet the same requirements?
Well, what we try to do is educate, to think about the exhaust systems to be all stainless steel construction like they are in Europe, because they require no maintenance. So if we compete with the Selkirk, Vanpacker, Metal Fab, Schebler, but if you specify the fiber insulation between the walls to always have that man-safe temperature, if you specify a stainless steel outer jacket, this is our standard product. We're competing every day with all stainless steel compared to a galvanized outer or aluminized outer spec. So what we're actually trying to do is to educate the market to say, look, think about the no maintenance. We're charging you the same price. So that's kind of what we're talking to you engineers about, if that makes sense.
Yes. Okay.
So there are 10 things that we can say that we're flat specified, but we're not changing the game. We're just having overlapping joints. So on the condensing boiler side, there's only actually 2 others that do overlapping joints, and that's Heat Fab and Duravent. No one else. I mean, all the other manufacturers have that butt-to-butt flange system. So we have a lot of people looking at switching to making sure that the joint systems are overlapping style.
Okay. So in the case of an exceptionally tall stack, through a high-rise building or whatever it is, where I have much more draft than I need and want, do you have a draft control system or damper, or would that be a different product?
No, we just do. We do have a draft control system we add on. We take a look at every job. We recommend that we do it before you put it out on the street. So just have us just go to your Buckley person, and we have our tech team take a look at it. If it needs the modulating damper, we offer that, and you get all the data sheets when that's sent back to you. Yeah, we do a lot of the damper systems because we have to make sure that we're providing the complete system for the for the engineer and also for the representative.
Okay, the one last question I had is you talked about fume hoods. So it sounds like it could be used for perchloric acid, but I mean, those ducts typically require sprinklers in the ducts. Can your system accommodate that?
Yes, we have standard nipples we put on for the sprinkler systems. Typically, they're a 1-inch nipple, but they can be whatever is required. We do that also for like the city of Las Vegas on their grease duct systems. They put a fire sprinkler every 10 feet. That's pretty common.
Okay, great. Thank you.
Oh, thank you. Okay, if no other question, we're going to wrap up and sign off. Everyone, we really appreciate your time, and stay safe, and we hope we have a chance to discuss more independently with each of you. Have a good day, guys.